Hello dear friends, welcome to Gate Academy Global. So before starting today's session, I would like to take the feedback from you guys, the quality of video as well as audio. Is it perfect or not? If it is perfect, just write perfect over the comment box and then we'll move ahead with the differential equation. And probably in today's class, we are going to smash the concept of the differential equation completely. And from next video onwards, we will be entering into the linear algebra. So anyways, I want the comment from each one of you, whether the quality of audio as well as video is perfect or not. Perfect or not? Perfect. Okay. So let me recall what we were discussing in the previous lecture. In previous lecture, basically I started the concept of the differential equation. At very beginning, I just was talking about why the differential equation is so powerful equation in compare with its solution. We talked about that, and at the same time we also talked the definition of the differential equation. A equation which contains at least one derivative term by default becomes a derivative differential equation. Even the differential equation was further bifurcated in the two parts. The first kind was an ordinary differential equation and the second kind is going to be a partial differential equation, and most of the time the questions are going to come from the ordinary differential equation. You can say out of 100 number of times, almost 95 number of times the questions are coming from the ordinary differential equation, yes, but from the rare of the rarest case the question also come from the partial differential equation. In next step, we talked about the order and degree which is connected to a certain ordinary differential equation. So highest derivative term present into the differential equation was said to be ordinary differential equation, and the degree of the highest derivative term, the degree, or you can say the power of the highest derivative term present into the system is called the degree of the differential equation. We also talked in the last class that in case of a differential equation, the calculation of the order becomes very easier. Degree becomes little bit trickier, and sometime you have seen ordinary differential equation may not be possessing the degree at all. So sometime it has been also seen that the degree does not consist in few of the differential equation. So before starting today's video, let me give you a brief idea what we are going to discuss. We are going to cover almost all domain of the differential equations from where the questions are keep coming. And probably the differential equation is going to be over in today's lecture, and from tomorrow onwards, obviously we are jumping into the linear algebra. And within the linear algebra, we are also not going into the properties part of the square matrix or matrix. Straight away we are jumping into the topic from where the questions are keep coming, like the concept of eigenvalue, concept of eigenvector. Thereafter we will be talking about the rank, the different kinds of solution of the linear equation, maybe infinitely many solution, no solution, sort of those concepts we are going to straight jump on, because the questions are coming from those domain again and again. And we'll also try to understand what is the basic fundamental behind the eigenvalues and eigenvectors, why the questions are keep coming from those domain. Definitely those values and those vectors should have a great use. Anyways, we'll be talking about that also. Is that part clear? So let me do one thing. Let me go to the working board. And you can write. We are going to discuss about the solution of differential equation. And here for the time being, I have used a differential equation which has order is equals to 1 and degree is equals to 1. So I am going to discuss about the solution of a differential equation having order is equals to 1 as well as degree is equals to 1. Order is equals to 1 as well as degree is equals to 1. Is that part clear? As far as this particular topic is concerned, the questions are keep coming. So first segment we can say within the solution of the differential equation, where we are going to discuss about the concept of variable separable. See, by just watching the problem, how you will notice that the problem can be straight away smashed using the concept of variable separable. You will just have a little bit structure of a differential equation. First of all, which type of problem it is? The problem is coming from a differential equation which is having order is equals to 1 as well as degree is equals to 1. But the name itself is a self-explanatory that the variables can be separated along its differential values. If you want, I can give you a little bit idea about it. If you talk about the structure of the variable separable, Structure of the variable separable, the structure would be, let's take you have got a function of x which gets multiplied with dx, and similarly at right hand side you have got another function, maybe y, which is getting multiplied with dy. So the name itself is a self-explanatory. The variables got separated with this derivative term. That means the function is a core function of x which is getting multiplied with the dx, and similarly the function is a core function of y which is getting multiplied with the dy. Perfect, sir. Thank you, Gurupal sir. Gurupal sir is here. A big heart to you, sir. Thanks a lot. I have asked to give me a little bit feedback. So any type of improvement, if you want, or any type of improvement you can suggest, sir, please suggest. Because you are one of the best teacher in India, and definitely I want your feedback. Thank you, sir. Thank you to be here. Is that part clear? So fx dx is equals to of gy dy. In last class, we were discussing the order of the differential equation is very same as the number of arbitrary constant which will come into the picture once we will talk about the general solution of that differential equation. So if we talk about the order of the differential equation is 1, so once you solve this differential equation, the number of arbitrary constant which will come into the picture, that is only 1, that is c for the time being. So anyways, this would be the structure of variable separable form, and once you talk about its general solution, so we will take integration both other side. That means you will take an integration towards the left hand side. That means the integration of fx along dx is equals to integration of gy along dy, and obviously one arbitrary constant c had to come into the picture. Is that part clear? So this is going to be your general solution form. Is that part clear? So rather doing much analysis over here itself, let me take a problem which have already been appeared in GATE examination. See, so this is the problem which is the first problem of the day. The problem have appeared in GATE Mechanical year of 2014. The problem was framed by IIT KGP, IIT Kharagpur. See, the solution of the initial value problem dy by dx is equals to of minus of 2xy, where the y at x is equals to of 0 is found to be 2. So I need to get the solution. Here the 4 options have been given in a form of MCQs, which starts from 1 plus e to the power of minus x cube, similarly 2 e to the power of minus x square, so on and so forth, Is that part clear? So may I know how will you start solving this problem? Is that part clear? How will you start solving this problem? See, try to understand whether this problem comes under the problem of the concept of variable separable or not. That means dy can be separated as a function of y, and similarly dx can go along with a concept or the function of x. Obviously, yes, we can do that. How we can do that? See, this y can be brought it towards the left hand side and dx can be brought it towards the right hand side. So what? Let me do one thing. Let me recall the problem, which is dy divided by of dx is equals to of minus of 2xy. Obviously, it's ordinary differential equation with having a degree as well as order as 1. What I am going to do, at first step, I will try to smash this problem out using the concept of variable separable. So we'll try whether the variables are separable or not. Obviously, it is. In next step, what I am going to do, dy is kept dy, the y has been brought towards the left hand side, and minus 2x dx, and you can easily see 1 upon y is a form of g of y, and similarly minus 2 of x is a form of f of x, or put together you can say the variables got separated with the dx as well as dy. Anyways, now the answer have also started coming. May I know what's going to be the best most answer? We'll see that. So the best most way is to just take the integration both other side. Rather going into the great details, sir, how the variable separable has to get solved. No, need not to worry about it. Just take integration both other side. Here as well as here. And obviously, an arbitrary constant c had to come into the picture. Once we talk about the integration of 1 upon y along with dy, simply it will lead log natural of y. Is equals to minus 2. The integration of x along dx is going to be x square divided by f2 plus of c. plus of C. So as far as the general solution is concerned, it's going to be ln of y. If you want, you can bring it towards right hand side. This and this goes off. So here it would simply become x square plus of C. X square plus of C. It's called the general solution. Why? Because so far a fixed value of the arbitrary constant has not been allocated. Is that part clear? So you should have the clear-cut idea about the general solution as well as the particular solution. Once we allocate a fixed real value to the arbitrary constant or in the place of arbitrary constant, by default the result becomes a particular solution. This is nothing but the case of general solution. But here one additional information has been clearly given over there. The worth of y was given at x is equals to 0, which is equals to of 2, and even once you'll see in the options, nowhere the arbitrary constant has been mentioned. What does it mean of it? That means this problem is asking about the particular solution. So many of the time in problem they will not be clearly mentioning whether they are talking about the general solution or the particular solution. By just seeing their options and by just seeing whether the initial information has been given in terms of x at certain y, you would be able to understand whether the problem is from the general solution or the particular solution. Obviously it's a problem from particular solution, so we need to feed the exact value of C. So here what I will do, I will use this y was function of x. That means the value of y was clearly given at x is equals to 0, which is equals to of 2. So what I'll do, I'll simply feed the value of x and simply will get the value of C. So the value of y, it's a ln of 2. The value of x has to be fed as 0, and the value of C was got to be ln of 2. So let me go down. Okay, I don't have any space. So here what I'll do, here it would become ln of y plus of x square is equals to of ln of 2. Is that part clear? And from here easily you can get the answer out of this. And once you solve this problem, you will get the answer as option B. So obviously many of the people have been replying with the option SP. So few things which we could understand or which we can conclude from this particular problem. The first problem, yes, it's a problem of a particular solution, and yes, it's a problem of variable separable. How did we know that? Yes, variables could be separated in terms of dx as well as dy. Is that part clear? So let me go back. This was the first case. Now we shall be talking about the second case. And here I am going to discuss about the linear differential equation with first order. Obviously, if we are going to discuss about the first order as well as first degree, that means we are going to deal with a differential equation which will have the order as 1. So now we are going to discuss about the linear differential equation, and it's also called Leibniz form of the differential equation, or Leibniz linear differential equation. Is that part clear? So let me talk about the structure of the Leibniz form of the linear differential equation. So the structure is gonna be dy by of dx plus of py is equals to of q. We have already talked about the concept of linear differential equation. May I know what would be the structure of P and Q? If dy by of dx plus of py is equals to of q has to be a linear differential equation. May I know that? Clearly this concept has been revealed in the last class. Tell me, what would be the structure of P as well as Q? What would be the structure of P and Q? I want the comment over the comment box. Comment over the live chat or chat box. Tell me what's gonna be the reply for that. What would be the structure of P and Q? Obviously. We have already said in the last class, this P as well as Q has to be a function of the independent variable. And as far as this linear differential equation is concerned, the independent variable is x. In that case, the P and Q could be any constant or could be a function of x. Is it part clear? So here P and Q could be any constant or any real value, including the function of x, So how do we solve this sort of problem? First at very first step, we get the value of integrating factor. May I know what used to be the integrating factor? It used to be e raised to the integration of p, which is a function of x dx. And thereafter we'll jump it to its general solution. Its general solution would be y, which gets multiplied with integrating factor, and thereafter integration of integrating factor getting multiplied with q, dx and s. It's a problem of the first order. Again, one arbitrary constant has to be taken back, and that is nothing but c. So let me put it. This is the structure of the Leibniz form of the linear differential equation, and that would be the general solution of the Leibniz form of the linear differential equation. And you can say one thing: out of 100 number of times, almost 40 number of times, the question do come from the linear form of the differential equation, which has order is equals to 1. Is the part clear? Obviously taking integrating factor it's called. So let me go down. Let me go to the next question. Now, the next question have come from GATE Electronics year of 2012. The problem was framed by IIT Delhi. So let me start reading the problem word by word, and you guys have to decode this problem and get the answer. You need not to see this, but still you try to solve by your own and then try to get the answer. With initial condition, again the value of x is being given at t is equals to of 1, which is equals to of 0.5. The solution of the differential equation t dx divided by f dt plus of x is equals to of t is. Now the four options are given. See, by seeing the option itself, one thing you could have been figure it out. It's a problem of a particular solution. Why? Because there is no arbitrary constant has been involved with any of the options. That's the first thing. Second, how straight away will you know that the problem have come from the Leibniz form of the linear differential equation? You need not to worry about it. What I will suggest, always try to solve the problem using the variable separable first. Always try to solve the problem using the concept of variable separable first. If you do not find that the variables can be separated, you can just go ahead with the linear form of the Leibniz linear differential equation. So okay, let me do that. So can you tell me whether we can use the concept of variable separable to solve this problem or not? I want the answer as yes or no. Can I use the concept of variable separable method to solve or to smash this differential equation? Many of the times it has been seen a simple form of problem can be easily solved using the concept of Leibniz linear differential equation, where the integrating factor has to be calculated, or straight away using the variable separable. Is the part clear? Tell me. Can I use the concept of variable separable or not? Still, see. If instead the t, it could have been like 0. If it could have been like 0, in that case, this problem could have been solved using the concept of Leibniz linear form of differential equation, or using the concept of variable and separable. Is that part clear? So sometime I have seen the many of the student even stuck at this point also. Like the problem is t dx by dt plus of x is equals to 0. Now they will start thinking, so should I use the variable separable technique, or should I use the Leibniz form, the linear differential equation technique? Both of the techniques are going to be converging to a same general solution, so you need not to worry about it. It's a part clear what I'm saying? Because you will be approaching to this sort of problem many of the times, where you will have the confusion whether the problem to be solved using the linear form or whether it has to be solved using a variable separable. But yes, here the function of t cannot be taken along with dt completely Similarly, the function of x cannot be taken completely along with dx. So this problem cannot be solved using the concept of variable separable. So we'll go ahead and we'll try to smash this problem out using Leibniz linear form of the differential equation. May I know how used to be the Leibniz form of the linear differential equation? First, the first derivative term has to be free from any of the term as well as constant. So what I'll do, I'll shift t towards the right hand side. How will you do that? Just dividing t both other side. So the structure would become almost a standard structure, which is dy divided by of dt plus of x divided by of t is equals to of 1, is equals to of 1. Is that part clear? So may I know what is the p over there? The p is nothing but the multiplier of, just a minute, it's a dx, no? It's a dx. The multiplier of x is gonna be p, here it's simply gonna be 1 upon t. And similarly, once we talk about the q is simply equals to 1. Is that part clear? First, I would focus over the integrating factor. It's a very, very asan problem. So integrating factor is gonna be e raised to the integration of p along with the independent variable. Do not get confused. Nobody should write dx over there. So here it would become e raised to p. May I know what's the p over there? It's a 1 upon t dt. And once I'll take the integration of 1 upon t, which belongs to in the range of ln. So here the result is going to be exponent to the ln of t would be simply equals to of t. Would be simply equals to of t. So if we talk about the general solution, may I know what would be the general solution? Keep in mind here it was a y into if. What was the y over there? The y was the dependent variable. But here you can see very well the x is changing with respect to the t. That means x is the dependent variable over here. So here it would become x, which will get multiplied with the integrating factor, would be equals to of integration of the integrating factor into q plus of c. Is that part clear? So here it simply becomes xt, x into t is equals to here it would become simply t. And what about the q over there? Where the q have gone? The q is simply equals to of 1 dt plus of c. So here it would become x of t is equals to of t square divided by f2 plus of c. And again, as I have said, I am interested into the calculation of the particular solution. So you will have a little bit information. Yes, you had over there the value of x at t is equals to 1. The value of x at t is equals to 1 is half. That means the value of x has to be kept as a half at t is equals to 1. At t is equals to 1. So the value of c was found to be 0. So once you will feed c is equals to 0, now this general solution will become a particular solution. So here I would be talking about particular solution by just feeding the specific value of c. So it becomes x of t is equals to of t square divided by f2 plus c, where the c becomes 0. So simply it's going to be x is equals to of t divided by f2. X is equals to of t divided by f2. So the best most answer is going to be option D. So as far as the problem which I have taken in today's class, the concept which we are dealing in today's class is a very easy topic, and most of guys are well aware with this topic, but still repeatedly I am saying it's a very, very important topic from where the questions are repeatedly coming. Is the part clear? So let me go ahead with the third kind. And it's the exact form of the differential equation. So let me focus over the structure of the differential equation itself. So the differential equation looks something like m, which is a function of x and y, getting multiplied with the dx, and similarly n, which is a function of x and y again, which is getting multiplied with the dy. But the m, which is a function of x and y, n, which is a function of x and y, follows a certain mathematical relationship. What is that? What is that? They follow the partial derivative of m with respect to the y. Keep in mind, here it is getting multiplied with the dx, and here the partial derivative has been taken place with respect to the y, because sometimes the student get confused over here. And similarly, has to be equals to of dou n divided by of dou x. That means the function which is getting multiplied with the x will get partial derivative in terms of y, and similarly the function which is getting multiplied with the dy would be partially derivated with respect to the x. And if this condition is met, this differential equation, or the first order differential equation, is called the exact form of the differential equation. Put it over the box. It's a necessary and sufficient condition for having this differential equation as a form of exact differential equation. Is that part clear? Is the part clear? Now let me focus over its general solution. Just focus over the differential form. What we do, we take integration of m dx, and here I would treat y as constant, plus I would take only those terms of n which is free from x, or I would say n term which is free from x, Obviously the integration has to be taken place with respect to the dy, and as it is a first order differential equation, again one arbitrary constant had to be studied with. Is that part clear? Is that part clear? So here yes, till this point each and everything is clear. So let me do one thing, let me go ahead with the next problem. This has been a design problem, because so far the straight problem from the concept of exact differential equation has not been appeared. By just watching this first order differential equation, let me know whether it's a form of exact differential equation or not. If it is yes, just write yes, and once it is yes, we'll move forward and we'll try to get the general solution of this exact differential equation, if at all it is a exact differential equation. If it is a exact differential equation. Tell me whether it's a form of exact differential equation or not. And if it is so, we'll try to get the general solution of this particular problem. But as far as the history of the GATE is concerned, around 7 to 8 number of times the problem have come from the concept of exact differential equation, but none of the time the question have come from the numerical angle. Straight away they will just ask the property by seeing this differential equation, when this differential equation would be qualified as a exact differential equation, and you have to say it's simply dou m divided by dou y is equals to of dou n divided by dou x. Repeatedly the problem have been coming. So now tell me whether it's a problem of exact differential equation or not. So the first input I have got it from Maurya Vikas, yes, exact. Arvind Tiwari, Sachin Kumar, yes. Oh, okay. How did we know that? Let me see that. See, y dash indicates the derivative of y with respect to the independent variable. May I know what's the independent variable? It's a x. So y dash is simply equals to of dy by dx. So I'll just arrange this first order derivative or the first order differential equation into the standard form. So what I'll do, I'll just write dy by f dx. I will take dx LCM. The dx would get multiplied with this. It will just remain with dy, and the dx once gets transferred towards the right hand side, simply it becomes 0. So what I will do, I'll simply rewrite this differential equation, which would be here it would become dx plus here sine of x plus of x square e to the power of y minus of 1, it would be dy is equals to 0. So clearly you can see it's a m. How it's m? It's getting multiplied with the dx, and which is supposed to be a function of x and y. And similarly it's a n, which is again supposed to be a function of x and y. See, whenever you have a problem in front of you, what you do, you always start with the first form, which is nothing but the variable and separable. You try to separate the variables in terms of f of x dx as well as g of y dy. Hell amount of time you can take, but never you will be able to separate them. Then try to get it out whether it's a form of linear differential equation. No, it is not. Then straight away we'll jump it to the exact form of the differential equation, and first we'll try to satisfy whether yes it is a form of exact differential equation or not. So what I am going to do, I am going to take a partial derivative of this function with respect to the y. Do not get confused in it. And here with respect to the x. So once we take a partial differentiation with respect to the y, that means the x as well as the function of x would be treated as a constant. So once we take a differentiation of this, the cos of x would be treated as constant, and the differentiation of y, which would become 1. Simply it's going to be cos of x. Similarly, here 2 of x, which would be treated as a constant, differentiation of e to the power of y, which is again e to the power of y. Let me see whether the left hand side and the right hand side is same or not. Let me differentiate with respect to the x. Sine of x would become cos of x, and similarly the differentiation of x square e to the power of y, where the e to the power of y would be treated as a constant, here it would become 2x e to the power of y, and the differentiation of a constant is simply 0. So at least we can conclude one thing: dou m by of dou y is equals to of dou n divided by of dou x. That means yes, the given form of the first order differential equation is a form of exact form of differential equation. So may I know what would be the solution of it? You need to take the integration, both are the side. So here you had to take y cos of x plus 2x e to the power of y. Obviously here it would be dx. That's a different story together. Once you'll integrate it, all of the terms which contains y would be treated as a constant, plus the integration of the second term. Only those terms are going to be picked up and to be fed over here, which is keep in mind free from x. Here it's not free from x, it would be dropped. Here it's not free from x, it would be dropped, and here it would just come as minus 1 dy is equals to c. Is that part clear? So let me go ahead. If y is being treated as constant and the integration is being started taking place, so here it will simply become y. The integration of cos of x would become sine of x. Similarly, just a minute. Similarly, here it would become 2 integration of x over dx would become x square divided by 2. 2 and 2 is going to be cancelled out. Here it would be simply x square e to the power of y. And here it would become minus of y is equals to of c. See why the problem does not come from the exact differential equation. Why? Because it takes hell amount of time to reach to the answer, and as far as the gate is concerned, they used to design a problem which generally gets solved within 2 minutes. Just a minute. Is there any mistake over here? Yeah, y sin x plus x square, just a minute, where it is x square e to the power of y minus y is equals to c. This is what the answer is. Till this point each and everything is clear now? So let me do one thing. Let me go ahead. with few more number of problems from your booklet, which is already been posted on Telegram group. Let me see if I can take few more number of problems. Now, if you guys have attended my last class, definitely can give the exact answer for the question number 40. Question number 40. I want the exact answer for the question number 40. Question number 40. I want the exact answer for the question number 40. Match each of the item A, B, C with the appropriate item from 1, 2, 3, 4, 5. The 3 number of differential equations have been given, and now the 5 different kinds of the wording has been written over there. So may I know how would be their connections? How would be their connections? So the student, when a function is exact differentiable, why it is called a point function? Point function. We'll see that. Can you guys tell me what's going to be the exact answer? The student who have attended my last class definitely could give the exact answer for this particular question. Could give the exact answer for this particular question. Tell me, what would be the best match for A? What would be the best match for A? Already I have talked this thing in great detail day before yesterday. So the student who have gone through those videos would able to get this answer obviously correct. So may I know what is the exact answer? A. No. Tell me. What's gonna be the answer? I'm just waiting for the reply from you guys. I'm just waiting for the replies from you guys. Okay, Priyesh is saying, sir, last class video not. See what is happening. Most of our office boy are in leave. That is why that is not there. But probably from tomorrow and day after tomorrow, whatever the videos have been released so far would be there within the playlist. Because once the video is freezed, no, we had to manually shift it to the playlist. That will be done. No need to worry about it. No need to worry about it. Tell me what's gonna be the best most answer. What's gonna be the best most answer? Many of the students could have been attended my last class. They can give the exact answer for this. Animesh Jana is giving A to 1. A to 1. See. Try to understand. Here, the derivative should not get multiplied with the function of the dependent variable itself. So if we talk about the at least first differential equation, this derivative as well as the y is nothing but the dependent variable getting multiplied together, which makes it a non-linear differential equation. Non-linear differential equation. Non-linear differential equation. I want the input from each and everyone. Non-linear differential equation. So if I want to really match the best most option, so it's gonna be non-linear differential equation, obviously. Non-linear differential equation. If you talk about the next, a1 d to the power of 3y dx cube plus a2y is equals to of a3. If you talk about the coefficients, they all are purely constant. So obviously it's gonna be a linear differential equation. Linear differential equation. And if you say the coefficients are constant. And if you want whether it's a homogeneous or inhomogeneous in form, see, right hand side is not 0, that means it's a non-homogeneous form. Homogeneous form. So may I know, you guys have given BS2. It's a linear differential equation with constant coefficients. Obviously, the B would get connected with 2. A would connected with 1. What about C? What about C? C. Here, till now, it's very perfect. It's a type of linear differential equation, but again, it makes it non-linear differential equation. Non-linear differential equation. So again, it would be a non-linear differential equation, but at right hand side, the value is 0. That means it would be a form of homogeneous. Anyways, we'll see that it's a non-linear differential equation. Non-linear differential equation here. Is the part clear? So if you talk about the best most answer, for A it's a 1, for B it's a 2, and similarly for C it's a 4. So the best most answer is going to be option A. Option A. This part is already been discussed in the last class, so you need not to worry about it. Is that part clear? So probably I could communicate what I wanted. Yes, my dear friend. Can you tell me what's going to be the best most answer for this? The question number 42. I am just giving the time frame of 1 minute, and you guys have to get the maximum value of y, where a certain differential equation is a governing differential equation between y as well as x, where the y is a dependent variable and x is an independent variable. I want the answer from it. Is the part clear? Tell me what's going to be the best most answer for the question number 43. Tell me what's going to be the best most answer for the question number 43. It's a well designed problem. Not 43, I think. It's a 42. Yes, 42. Tell me. Sir, your 10th lecture is missing. No issue here. Probably today or day after tomorrow it will get added in your playlist. Already the link has been shared in my group, so probably the guys who are there in my group definitely could have got that link. But anyways, it will take probably 1 or 2 days to go into the playlist. Tell me what's going to be the best most answer. Then y max is equals to, more or less it's a problem. Sir, you did a mistake. May I know where I did a mistake? For his MD. You can just pinpoint over there. So I'll definitely will try to cross correct. Anyways, just focus over the question number 42. So for his, I would say just focus over the question number 42, and we'll try to move ahead from here. Tell me how the question number 42 would be dealt. This is what my question is. I want the answer from each one of you. See, now let me start solving this problem. Here comes my solution. See, here it's a dy by f dx plus of 2 10 x, which is getting multiplied with y, is equals to of sin x. Again, it's a form of Leibniz for the linear differential equation. Yes, obviously. How? Because here the p has to be a function of independent variable alone. Obviously 2 times of 10x, it's a function of x itself, and similarly q should also be the function of the independent variable alone, including constant. It is there. So first I would focus over the integrating factor. May I know what used to be the integrating factor? It's going to be e to the power of p over dx. Is that part clear? So here it becomes e 2 times of 10x dx. Now you should be very clear about how the integration would be made of 2 times of 10x dx. So what I'll do over here, see. what I will do over here, the 2 has been brought it out. The tan x can be written as sine of x divided by of cos of x dx. So in next step what I am going to do, I am going to take cos of x as t, and once I will take cos of x as t, so differentiation of cos of x would become minus of sine of x dx is equals to dt. So I think you guys are well aware how to go ahead with this sort of problem, because already you guys have gone through the 11th as well as 12th. So may I know what's going to be the result over here? It's going to be minus of ln of cos x. Yes. Yes or no? Is the part clear? And now I want the answer from each and everyone. So you can do one thing, you can take cos of x as t. So it would become 1 upon t is going to be ln of t would become ln of cos x, and just minus sign would come out. So one answer have already come as minus half. I want the rest of the answer. So here it would become, let me go over here. Here it would become e to the power of minus sign, and 2 would become minus 2. I know that, I know a of ln of b is equals to of ln of b to the power of a. So minus 2 would go into the power of cos x. So here it would become exponent of ln of cos of x to the power of minus 2. Is that part clear? Minus 2. Ln and exponent, they goes out, and here it would simply become 1 upon cos square x, which is equals to of sec square x. This is what the value of integrating factor is. Is that part clear? So let me take its solution. If you talk about its general solution, what's going to be the general solution? May I know? First, the integrating factor would get simply multiplied with y. So here it's a y, and at right hand side, the integrating factor, which is sec square x, has to get multiplied with the q of x. What's the q of x over here? It's a sine of x plus of c. So here let me take it again. It's going to be sec square x, which will get multiplied with y. And here, may I know what's going to be the result out of this? See, the sec square x can be written as cos square x dx plus of c, and here it would become y sec square x is equals to of sine divided by cos of x is nothing but tan of x and similarly sec of x plus of c. So let me go down, and may I know what's going to be the result out of this? So here it's simply going to be, just a minute, here it's simply going to be y sec square x is equals to integration of sec x into tan x is simply equals to of sec x plus of c. Let me go down. One more information is clearly given with this problem. At pi by 3, value of y is 0. If the value of x has been kept as pi by 3, the value of x is being kept as pi by 3. So here it's going to be 0 sec square of pi by 3 is equals to of sec pi by 3 plus of c. So here this goes off. May I know what's going to be sec pi by 3? The sec pi by 3 is nothing but, you can just write it over here, the c is going to be minus of sec pi by 3. I want the answer from each and every one. So far so many type of questions I have been taken. So now I understand you guys would be able to crack this problem. And once this is come out, you will use the concept of maxima and minima. That is why such a big question has been designed. although these questions are rarely asked in gate examination, I think probably it has not come in gate examination, but still what I say, you are not focusing over value of y, you are focusing over the maximum value of y, maximum value of y. So just let me give 30 seconds. You first find the particular solution, and from the particular solution find the value of y, and then from the y you try to get it the maximum value of y. So I want the answer from each one of you. I want the answer from each one of you. Tell me, what would be the best most answer? What would be the best most answer? Tell me. Tell me what would be the best most answer. I am waiting for the reply from you guys. I am waiting for the replies from you guys. Otherwise, I'll leave here itself. Take 1 minute and get the answer. 3 by 8. 3 by 8. What else? What else? Tell me. What else? Tell me. What else? Anyways, now this question goes to your homework. Till this point, I have communicated each and everything. This would come as a part of C. You will get a y, and if it is required, use the concept of maxima and minima, which has already been taught in the class. That is what I am saying. That is what I am saying. The questions are going to club now. Initially, you were talking about the concept of maxima and minima. Here you are talking about the concept of differential equation. But what happened? At the same point, now the differential equation and the concept of maxima and minima got clubbed. No, so many different tenses we are getting. Sir, -2, 3 by 8, 1 by 8. That is what I am saying. Do one thing. We'll have a discussion of this problem on our group. So the student who are very new to this video, you can just join my group. And whatever the type of doubts we guys are having, definitely we are going to discuss over there. 1 by 8, Anurag 1 by 8, Maurya 1 by 8, Amal -2, 3 by 8. So many number of answers we are getting. 1 by 8. Anyways, we'll discuss over the group itself. Now, going into the next concept, just I wanted to ask one thing. May I know which are the topic you guys find yourself very difficult? You can just comment over here. So in future, I'll stress more on those topics where the people find themselves more difficult. As far as the mathematics is concerned, I am very thorough in mathematics. So whatever the topic you say, sir, this type of topic we are finding ourselves very difficult, definitely I'll put more stress over those topics. You can just put it comment over. Tell me. Vector calculus, conditional probability. Okay. Keep on. Your vector calculus. I used to take the classes for electromagnetic field theory. Literally, if you guys are learning vector calculus, you are just going to enjoy. But as far as the crash course is concerned, we'll just discuss about the important factors of the vector calculus. Otherwise, really, I would say the one topic where really your visualization goes to the infinite, and that topic is nothing but the vector calculus. But as I said, we are running with the crash course. We had to comprise each and everything into the concise form, but still, I would try to cover the vector calculus in the very great manner. Complex variable, no issue, I would cover that. Probability, why people are so afraid with the probability? Vector calculus, you need not to worry about it. Because I used to take a class for EMFT, and the EMFT is the application part of the vector calculus, so you would be more than comfortable about it. No issue. Okay, no issue. Probability, many of us are finding difficult probability. Anyways, no issue. We'll go ahead. Now, let me go into the higher degree higher order differential equation, but still we are going to deal with the linear form of the differential equation, and the coefficient we had, no, a0, a1, a2, a3, for the time being they have been kept constant. They have been kept constant. I want to visualize the vector calculus as you have made me understand that you need not worry about it. You need not worry about it. The student who have studied from me, studied EMFT from me, definitely they know about it. They know about it. Anyways, now you can write the solution of the differential equation. Solution of the higher order differential equation. Now what I am going to do, now I am going to fix the higher order differential equation is a type of linear differential equation. You can just write solution of the higher order linear differential equation. Higher order linear differential equation with constant coefficients, constant coefficient. With constant coefficients. So may I know which type of structure we would be dealing with? We are going to deal with a differential equation which is linear in nature and the coefficients are going to be constant. So probably we are going to deal with, let's take a second order differential equation. You can write r, which is supposed to be a function of x, and again I would focus over the general solution. See, the general solution, if we talk about the general solution of the above linear differential equation with the coefficients as constant, what does it mean of it? Although being a linear differential equation, a2, a1, a0 could have been the function of x also, but I have deliberately made them constant. And keep in mind, out of 10 number of time, whenever the question comes from the higher order linear differential equation, the problem would be coming from this pattern alone, where the coefficients are constant. Now the people may ask, sir, why this question used to come? See, whenever you are dealing with any practical scenario, I would like to show few of the practical scenario. You will get to know most of the time you encounter with the linear differential equation where their coefficients used to be constant, like series RLC circuit, RLC circuit, RL circuit, LC circuit, mass damper, spring constant, anything, anywhere, the result used to be a linear differential equation with the constant coefficients. If you want, you can just write it over here. Like, may I know what would be the KVL over here? The electrical guy can understand in the better way. What would be the KVL over here? Let's say the current IT is flowing through this circuit. So the V would become L times of di by of dt plus of R times of IT. May I know whether it's a linear differential equation or not? Obviously, sir, it's a linear differential equation. May I know what are the coefficients? We have got a coefficient as L as well as R. May I know whether the L and R is supposed to be a function of t or not? If L and R is supposed to be a function of t, still it will be a linear differential equation, but most of the cases in practical we find the value of L as well as R used to be constant, and if the value of L and R is a constant, it would be a linear differential equation with the constant coefficient. And similarly, in case of mechanical also, if you are dealing with the mass, so if you talk about the force exerted on mass, so it's gonna be m times of d square x divided by dt square. Obviously, may I know m, would it be function of t? Mostly I assume the mass is fixed. That means the m is fixed, and whatever the differential equation you are making, which is gonna be a linear differential equation, all of the coefficients are found to be constant. So keep in mind, most of the practical scenario, once we deal with the either circuit level study, either maybe mechanical or chemical level study, you will be getting this terms as a constant, and that is why they focus more over the constant coefficient. So let me do one thing, let me rub it out. As such, it is not that important. Is that part clear? So the general solution will have the two part. See, will have the two part. Let's y is equals to of CF plus of PI. The CF is called complementary function, you can write over here, and similarly the PI is called a particular integral. Particular integral. I repeat, CF stands for complementary function, and similarly PI stands for particular integral. Particular integral. CF is also called zero input response. Zero input response. Why it's called zero input response? We'll see. While we'll calculate CF, forcefully we'll keep R of x as 0. And may I know what is R of x? R of x is nothing but the input to the complete system. Complete system. If you guys would be able to recall the same circuit. See, what was the KVL? The KVL was equals to of V is equals to of L di by dt plus of R. So may I know what are the different terms and what are the different terms it stands for? See, this stands for input, obviously. The circuit got excited with V. This is nothing but the dependent variable and this is nothing but the independent variable, and here the L and R are the constant, and hence they are said to be a constant coefficients. But what happens if the V has been forcefully kept 0? What does that mean of it? That means you are studying the system when the external voltage has been fed to be 0. Is that part clear? So anyways, it's called zero input response. Or. The CF alone is called homogeneous solution. Why it's called homogeneous solution? See, in case of linear homogeneous equation, the input used to be 0. And now if the input itself has been made 0 and thereafter the calculation of this differential equation has been calculated, which is accounted by CF, that means the CF would be the solution of the homogeneous form of the linear differential equation. Although it's a non-homogeneous form of the linear differential equation if Rx is not equals to 0. But if Rx is forced to be 0, and whatever the result we get out of this, in that case we will be calling it as CF. Is that part clear? And it's called particular integral. Let me go down. The CF is solely depends on keep in mind, the CF is solely depends on roots of auxiliary equation. We'll see what is that. The roots of the auxiliary equation. Whereas PI depends on auxiliary polynomial and the input. I repeat. CF solely depends on auxiliary equation. We'll see how the auxiliary equation is found. Whereas PI is calculated, or PI has the impact from f of d, which we call it auxiliary polynomial as well as input. Is that part clear? So let me go down. So let me see where we are focusing ourselves. We are focusing over a linear differential equation, maybe higher order. But yes, the coefficient we had, the A0, A1, A2, A3, they all are constants. That means A2, A1, A0, they all are kept as a real constant. Now, if we talk about its general solution, the general solution will have the two parts. You had to calculate using the two different processes, which includes CF, which includes PI. The CF stands for complementary function, the PI stands for particular integral. If we talk about the CF, now in future they may ask why the CF exclusively has been calculated, and the CF stands for what? The CF stands for the response when the input is forcefully kept 0. Or I can say it's the response of a same linear differential equation when it is presumed or when it is assumed as a homogeneous form. Why? In case of homogeneous linear differential equation, this R of x is kept 0. Now, if we talk about the CF, how do we calculate CF? Anyways, we are going to talk about that. First, just focus over the f of d, which we call it auxiliary function, and we will compare with 0. So the values of d which satisfies f of d is equals to 0 would be called as roots of the auxiliary equation. The roots of the auxiliary equation is going to decide your CF. The different varieties, the different structures of roots are going to have the different varieties, the different structures of the CF. But as far as the PI is concerned, the FD and RX together is going to decide your PI. Till this point, each and everything is clear. If it is clear, just write clear. Just write clear, we'll move ahead. We will move ahead. We'll move ahead. So focus over the calculation of CF. Calculation of CF. Is that part clear? So just focus over the calculation of CF. What I do, first I focus over the f of d and I compare with 0. So let me do one thing, let me recall. We had the differential equation. In first step, I would forcefully feed the input as 0. Similarly, d of dx would be replaced with differential operator, which we call it capital D. That means in future d square by of dx square would get replaced with the d square, so on and so forth, or dn by of dx to the power of n would get replaced with the d of n. Is that part clear? So let me replace that. So here it would become a2 of d square plus of a1 of d plus of a naught, and the y would be common from here. Here it would become d square of y, and here it would be just y. So the y becomes common over here, and right hand side is simply equals to 0. And here you will be getting a2d square plus of a1d plus of a naught is equals to 0, and it's called auxiliary equation. What it's called? It's called auxiliary equation. Keep in mind, it's called auxiliary equation. So let me mark it down. It's called auxiliary equation. Auxiliary equations. The roots of the auxiliary equation is going to decide the structure of the CF. So may I know how many types of the roots, how many characters of the roots you can have? Now, how many roots you'll have? It's a quadratic equation, so definitely two number of roots you'll have. The varieties of the roots you can have, you can just write the varieties. Varieties you can have. First, let's take the roots are found to be m1 and m2. May I know what about the nature of them? Both of them are real and distinct, separated. Real and distinct. In that case, your general solution, CF is simply gonna be C1 e to the power of m1x plus of C2 e to the power of m2x. This could be the first way. Or this could be the first fundamental. Is that part clear? Now, secondly, you can have a situation where the roots are found to be real, but they are repeating. Like the first root is m1 and second root is also m1. The roots are real but repetitive. The structure of the CF would become C1 plus of C2x e to the power of root m1x. Is that part clear? Now, you can have the third case. The roots are found in a form of complex conjugate. The roots are found in a form of complex conjugate. So the structure would be CF would be equals to e to the power of alpha x C1 cos of beta x plus C2 sine of beta x. One of the common factor in all of three. How many number of arbitrary constant got introduced? 2. Why the 2 number of arbitrary constant got introduced? Because the order of the differential equation is 2. How did you know that the order of differential equation is 2? Because the auxiliary equation which you have got it, may I know what's the degree of this auxiliary equation is 2, and hence the order is also 2, and hence the number of arbitrary constant which would be coming, it's gonna be 2. So as far as the calculation of CF is concerned, CF would include the auxiliary, would include the arbitrary constant, whereas Pi would be free from any arbitrary constant. Next, the number of arbitrary constant which would be possessed by CF would be precisely same as the degree of the auxiliary equation or order of the differential equation. Is that part clear? So let me do one thing. Let me fatafat give you few number of problems. You guys had to give its CF. The first question. Find the CF for given linear differential equation. Let me take the first question. First question is d square y by of dx square let me take this as 3 of dy by of dx plus of 2y is equals to maybe x. That's what your first question, and you just had to focus over the CF. That could be your first question. Let me go to the second question. D square y by of dx square 2 times of dy by of dx plus of 2y is equals to of 0. That could be your second question. Similarly, third question. D square y by of dx square 2 dy by of dx plus of y is equals to maybe x square. I want the CF for the question number 1 as well as 2 as well as 3 over the comment box. Tell me what would be the CF for the first question, second question as well as third question. If you want, you can change this problem a bit. You can change it to the T now. Tell me what would be the CF for the first question. See, what we'll be doing over here. First, this x would be, just a minute. This x would be killed now. Why? Because it's in the place of Rx. Now, in next what I'll do, the d by of dx would be replaced with capital D. So here you will just focus over the auxiliary equation. It would become d square 3 of d 2. The y would come out. It would get replaced with 0. Simply it's gonna be d square plus 3d plus of 2 is equals to 0. So now you can use the middle term split. What is that? Here it would become d plus of 2d plus of 2 is equals to 0. So from here the d is taken out, it becomes d plus 1. The 2 is taken out, it becomes d plus 1. You will be getting the two values of the two roots of the auxiliary equation, which is -1 and -2. minus 1 and minus 2. So CF can be easily found, and which is equals to minus 1 minus 2. Let me rub it out. So here it would become CF is equals to C1 e to the power of m1. m1 is nothing but minus 1, which is getting multiplied with x. Simply you can write x plus of C2 e to the power of minus 2x. Why so? Because if you talk about the structure of the roots, they were real as well as distinct, and hence its CF would be C1 e to the power of m1x plus C2 e to the power of m2x. Now deliberately what I did, the roots of the question has been changed a bit, and once you will take about its auxiliary equation, it would become d square plus 2d plus 2 is equals to 0. So may I know what's gonna be the roots of the auxiliary equation? Probably it's gonna be minus 1 plus minus j. So the value of alpha, the alpha is nothing but minus 1, and similarly value of beta is nothing but 1. So if the roots are in form of complex, so here the CF simply becomes what it becomes, e to the power of minus mx or e to the power of alpha x, which would become e to the power of minus x, C1 cos of beta x, which is 1, plus of C2 sin x. Is that part clear? What about the third one? Again, the third one has been chosen in such a way. Now the third question is almost differ from the question number 1 as well as 2. Is almost different than the question number 1 and 2. So let me change the color. If we talk about its auxiliary equation, the auxiliary equation is going to be simply d square 2d plus of 1 is equals to 0. It can be written as d plus 1 to the power of 2. So the d would have repeated real roots at minus 1. So may I know what would be the CF of this? The CF is simply going to be C1 plus of C2. Keep in mind here it won't be x. Why? Because the independent variable is t now, no? So here it becomes t e to the power of m1x, but rather m1x, now you'll have m1t. So here it would become minus t. So all three categories of the roots has been covered by taking the three number of problems. Is that part clear? Now focus over the PI. Focus over the PI. For the PI, as I have said, you had to focus over the two terms. The first, auxiliary polynomial, and second, the input R of x. You can have the different varieties of R of x, and based on the different varieties of the R of x, you will have the different values of P of I. Let me see part by part. The first question could be, or the first pattern could be, like you have got your R of x as e to the power of ax, R of x. So its PI is gonna be f of a simply equals to of e to the power of ax, provided f of a is not equals to 0. Is that part clear? Now, unfortunately, if f of a is found to be 0, you will have another process. What you will do? You will just differentiate denominator, or you will just differentiate the polynomial of f of d with respect to the d, and you will feed d is equals to a thereafter, and just x gets multiplied at numerator. And I hope again f des a is not equals to 0. And again, if f des a becomes 0, what will happen? Denominator becomes 0 and complete structure vanishes. And similarly, if it is happening, you have to keep raise the power of x, and it becomes and this goes on, and this goes on. Is that part clear? Is that part clear? So let me take a problem and you guys have to give the exact answer of the PI for that particular question. So let's take, the question is sort of d square y by of dx square plus of 2 dy by of dx plus of y is equals to of e to the power of 2x. You guys are very well aware with the CF. How will you calculate the value of CF? E to the power of 2x has to be forced to be 0, because first we had to make this linear equation as a form of homogeneous equation, then only you will get the value of CF. But anyways, my focus is not CF now, my focus is PI. My focus is PI. So we will focus over the PI. See. By watching the problem itself, you must be able to extract f of d. You need not to follow 1 or 2 or 3 number of steps to get the value of f of d. Otherwise, you would not get the good marks in GATE. So what you must be having, you must have the clear-cut idea what would be the f of d. D by of dx would be replaced with a capital D. Okay, sir. Okay. So here it's gonna be simply d square plus of 2 of d plus of 1, which is f of d. And here instead the d, I need to feed d is equals to a. May I know what's the a over there? It's a 2. Just a minute. It's a 2. Agreed. So here it becomes e to the power of 2x, and here it's gonna be 4 plus 4, that's a 8, plus 1, that's a 9. That's a 9. Is that part clear? Now, try to understand, rather having e to the power of 2x, it could have been e to the power of 2x plus 3. Then what could have been the situation? What it is, e to the power of 2x, okay? The first question is e to the power of 2x itself. What I did, deliberately I have changed e to the power of 2x plus 3. See, e to the power of 2x plus 3 can be written as e to the power of 2x into e to the power of 3, no? So once you will calculate its PI, it could have been written as e to the power of 2x into e to the power of 3, that e to the power of 3 would come out. So if you have a problem e to the power of 2x plus 3, what will happen? E to the power of 3 will come out, and exclusively you have to deal with the e to the power of ax. So that is why I would like to change a little bit. May you know, if instead the e to the power of ax, if it is e to the power of ax plus b, what will happen? It will become e to the power of ax plus b. E to the power of ax plus b can be written as e to the power of ax into e to the power of b. E to the power of b can be brought it out. Is that part clear? So let me go down. Do not get confused with it. Yes. But if instead the e to the power of ax, if it is e to the power of ax plus b, you have to follow the same rule where the e to the power of b can be brought it out at very first instance. Is that part clear? Till this point, definitely the clear must be there. No. Let me go down. If you have a second structure, here r of x is a sinusoidal signal, obviously including a cosinusoidal signal. R of x is either sine of ax plus b or cos of ax plus b. Then I am interested into the calculation of its particular integral. So the particular integral, what I'll do, the sine of ax or cos of ax plus b, I'm just writing any of them, would be applied over the auxiliary polynomial f of d, and its pi would be sine of ax plus b, and here at denominator, instead the d square I need to feed the value as minus a square, and again I will have an assumption that the denominator is not 0. Again and again I am not going to write that. But if f of d square is equals to of minus a square becomes 0, what will do? You will take a first derivative and the x will get multiplied. Again, if the first derivative of the function at d square is equals to minus a square found to be 0, Is the part clear? Similarly, again what I'll say, if the double derivative takes place, if the denominator becomes 0, again and again you had to correct it back and back. Is the part clear? Why we use minus a? No, see, if you want the derivation, I can easily give you the derivation. As far as the engineering mathematics is concerned, I have gone through the each and every derivation. You need not to worry about it. If you say, I'll start teaching that also. Even we don't teach in the full course, so you need not to worry from where those concepts have come. Is that part clear? Okay, so f of d square is equals to of f of d square is equals to of minus a square. So now the problem goes to you guys. Let's take the problem. D square y by of dt square plus of, you can write, plus of is equals to sine of x. Just focus on this problem, and try to get the pi for this. You need to get the pi for this particular problem. So what would be your approach? First focus over the f of d. May I know what's going to be the f of d? It's going to be d square plus of 3 of d plus of 2 And here may I know what's the a over there? The a is simply equals to of 1. Anyways, you can just write sine of x as it is. In next step, what I am going to do, once I get it the pi for this, instead the d square minus of a square has to be fed in. May I know, instead the d square minus of a square means minus of 1 square has to be fed in, which is equals to of minus 1. So here d square would be replaced with the minus 1. Nobody should touch 3 of d. No, 3 of d would remain as it is. 3 of d plus of 2. Until and unless this complete expression is free from d, you could not calculate the value of pi. So still further process has to be done. So what we will do in further? So sine of x, sorry, it's the sine of t, no? Okay, let it be t, no? Let it be t. It's a t. It's a sine of t, and again it's a sine of t. Is that part clear? Sine of t. Here it's going to be sine of t. Is that part clear? Here 2 minus 1, that will become plus 1, and here it become 3d plus of 1. But still at denominator, the values has to be fed in terms of d square. So for making denominator as d square, I will be taking the concept of rationalization. May I know what would be the concept of rationalization? Till this point, each and everything is clear or not? It becomes 3 of d, it becomes minus 1, obviously it becomes minus 1, and this becomes 2. So may I know what's the answer you guys are getting? Ayush Kumar, you are always saying signal. See here, signal is the application of the mathematics. So Ayush, if you are finding something new, you did not worry about it. The course I have already elaborated very first instance. The complete course would be covered, which is common in all of the branches, including chemical. So you need not to worry about it. See, then what I'll do? 3d minus of 1 divided by of 3d minus of 1 into 3d plus of 1, which would become 9 times of d square minus of 1, and here simply sin t would be there. Again, I would be using the same concept. What is that? Instead of d square, I need to feed minus of a square, which is equals to of minus of 1. So here it becomes minus of 9, minus of 1, that becomes minus of 10. And the component which is left out is 3 times of d. May I know what's the d over there? The d is nothing but the derivative operator or differential operator, minus of 1 sine of t. So, okay, let me start. 3 dt would get applied over the sin t, it would become 3 times of cos t. 3 times of cos t, and similarly minus of sin t divided by of minus of 10. Minus of 10. The minus has been taken common towards the numerator as well as denominator, so the result which we are getting is simply going to be sin of t minus of 3 times of cos of t divided by of 10. Is that part clear? So may I know? Maurya Vikas have given probably the correct answer. Yes. So the value of pi is going to be sin of t minus 3 cos t divided by of 10. Clear till this point? So probably you guys must be clarity till this point. Now you can have the last variety, the third variety I am saying. Third variety where your input r of x is a polynomial. You can say x to the power of m, where the m is always integer, positive integer. So how to solve this sort of problem? What I will do, see. The x to the power of m would be operated with f of d. The f of d would be brought towards the upside. And I will take its power series expansion and would apply over the x to the power of m. And I will try to get its pi. Theoretically, it might be looking very difficult, but once you are do one answer, definitely this problem is going to be very easy. Is that part clear? So now let me take a problem. Deliberately what I am doing, I am going to take a linear differential equation whose order is 1, just to deliberate this problem in the great detail. Let's take the problem is somewhere dy by of dx plus of 2 times of y is equals to of maybe x square plus of x. Is that part clear? And basically I am interested in to the calculation of particular integration. What I will do at denominator, I would have the polynomial of d, which is simply going to be d plus 2. And similarly at numerator we have got r of x, and what it is? It's the x square plus of x. Is that part clear? So whenever you have input in terms of a polynomial, what you will do? The denominator will be brought up towards the numerator. So you can do one thing more, the 2 can be taken common. So it would be simply left out with x squared plus of x 1 plus d divided by of 2. So in next step what's going to happen? It will remain half. 1 plus d divided by f2 would go towards the numerator side. 1 plus d divided by f2 would go towards the numerator side, and it would become inverse, and here it is going to be applied over the x square plus of x. Now what's the benefit we got out of this? We have got a power series expansion. You can have a power series expansion of 1 plus d divided by f2, and you will be keep expanding 1 plus d divided by f2 to the power of minus 1, such that from there onwards all of the terms are 0 once it is getting applied over the x square plus of x. May I know what is the expansion of 1 plus x to the power of minus 1? It used to be 1 minus of x plus of x square, so on and so forth. It goes on. So here it becomes 1 minus d by 2 plus of d square by 4 minus of d to the power of 3 divided by of 8, and it goes on. Has to get applied over the x square plus of x. Is that part clear? But now you can see very well the highest power of the polynomial is 2, and now if you take the power which is greater than equals to of 3, what will happen? If they gets applied over this polynomial, they become 0. they become 0. Yes or no? Obviously yes. So what I will do, I will approximate this expansion till this point, So whatever the calculation has to be made, it has to be made between this as well as this. So now the 1 is getting multiplied with the x square plus x, that would be simply x square plus of x. Minus half would come out, The d is nothing but the derivative operator with respect to the x. The differentiation of x square would become 2x and the differentiation of x would become 1. Plus. Here it becomes 1 upon 4. And the double differentiation of x square plus of x, the term x, if the double differentiation takes place, that becomes 0, and the double differentiation of x square would become just 2. And once you simplify the complete expression, you will get to know the pi is in front of you. So you will get the pi out of this. Is that part clear? So whatever the result comes from here, that's gonna be your pi. Is that part clear? Now the last one, the Cauchy's, write down Cauchy's. This problem I have seen repeatedly, it is coming in GATE examination. Cauchy's linear form of the differential equation. Put it star mark over this question. Cauchy's linear form of the differential equation. So let me see how the structure of the Cauchy's linear form of the differential equation looks like. It's a a naught like x square d square y of dx square, a naught x dy of dx. Here you can write this as a1 a2 y is equals to maybe q, which is a function of x. Keep in mind, so far we were talking about the higher order differential equation which is linear in nature, whereas their coefficients were constant. But here their coefficients are no more constant. But here, one exact fundamental or exact structure you are finding, what it is, when the double derivative proceeds, the x square is there. When the first derivative proceeds, the x is there, and similarly if the nth derivative proceeds, there x to the power n would be there. So if you have this sort of problem, this problem can be changed to the linear differential equation with constant coefficient. I repeat, probably 7 to 8 number of times the problem have straight away come from this topic. So what is the difference between the CF and PI which we were calculating so far and between them? The CF and PI when we were calculating, see, this was kept d square d. Similarly here we were getting only constant as a coefficient, but here the coefficient is a function of x. Not only they are function of any arbitrary x, they have got a strict relationship. What it is, when it's 2 it's a 2, when it's a 1 it's a 1, similarly when it's a n it's a n. So that form of the linear differential equation, it still is the linear differential equation. Why? Because the derivative is getting multiplied with the independent variable. So this form is called Cauchy's linear differential equation, but this Cauchy's linear differential equation can be changed to the linear differential equation with the constant coefficient, and once you are changed it to the linear differential equation with the constant coefficient, the CF and PI can be easily calculated, and again this problem can be smashed out. But how we do that? So only one change we take. Instead the x we feed e to the power of t. Instead the x we feed e to the power of t. Is that part clear? Similarly, d of dx is fed as capital D. D square of dx square is fed as d into d minus 1. And similarly, d square of dx to the power of 3, although you will not have order of 3 and more, but still it would be keep decreasing. That many replacement you had to do. And whenever you refer d, keep in mind the d is nothing but dou of dou x. Is that part clear? sort of this. So you can do one thing, you can keep aside for the time being. Yes. So here, may I know how it would get replaced? It would get replaced with the d minus 1 of y. Similarly, may I know what it will get replaced? It will get replaced with the d of y. And whenever we refer d no, keep in mind we are referring d of dt, yes, d of dt. That many input you had to be remembered. That many input has to be remembered. That's it. I am going to take a problem which have already come in gate examination. So let me go there. Yeah, so many questions have come now. This problem you can do afterwards. Yes, the question number 7 probably. Question number 7. Let me see this problem and try to understand whether it's a problem of Cauchy's linear form of the differential equation or not. Cauchy's linear form of the differential equation or not? Obviously, yes, it is. Why? Because here it's 2 and the power of x is also 2. Here it's a 1 and the power of x is also 1. And hence, definitely, it's gonna be a type of Cauchy's form of the linear differential equation. So, what you guys are doing? See. X square d square of dx square would be simply fed as d minus 1. Similarly, x dy by of dx would be simply fed as d. And if at all you could have the dx to the power of n, dn y of dx to the power of n, this could have been d minus 1, d minus 2, dash d minus of n minus 1. Yes. I repeat, whenever you have this sort of problem and the problems are keep coming from this domain. So this many replacement you had to do. Is that part clear? So x square d square y by of dx square would become d minus 1. May I know anything else apart from this? No, it's a 1. So d minus 1 would get multiplied with 1 alone. And here it becomes minus. X times of dy by dx is simply equals to of d. And here it would be 1. The y would be brought out as a common. And we are interested in CF, so just I'll take the right hand side as 0. Although in this problem, the right hand side itself is 0. That means the value of pi is simply going to be 0. Is that part clear? What I will do at next, I will just expand them. It would become d square minus of d plus of 1. I repeat, d square minus of d plus of 1. Y is equals to 0. May I know what would be its general solution? The general solution would have the two part, the CF, and as the input itself is 0 by default, the pi would be 0. Is that part clear? Pi would be 0. Agreed? So may I know what would be CF? So just focus over the d square minus of 2d plus of 1, and which would be equals to 0. And here it becomes our identity d minus 1 whole square is equals to 0. So you will be getting the two values of d, that's a plus 1 and plus 1. Is that part clear? So obviously you can get the general solution. Y is equals to, here y, yes, y is there, y is equals to of y is equals to of, you have got the two roots and they are repeated and real. So simply it's gonna be e to the power of 1 into x. No, it's not x, it's just simply t. That is what I said. No, that is what I said. In future, whenever I am referring d, no, the derivative is in terms of t, is in terms of t. So it will become y is equals to of e to the power of t, e to the power of t. Within the bracket, you will have c1 plus of c2 into t, into t. Agree? I repeat it again. Probably you guys could have confused so far. Whenever you have x square d square y of dx square, you just replace with the d into d minus 1. If you have x cube d cube y divided by dx cube, you replace with the d minus 1 d minus 2. If you have x to the power of 4 d to the power of 4 y dx to the power of 4, you had to replace with the d minus 1 d minus 2 d minus 3. But keep in mind, the problem is not coming beyond second order. Then what will happen? This x square is already gone with this, x is already gone with this, so you will be left out with a, where it is, you will be left out with a auxiliary equation of polynomial which is free from x, and now from here you can easily get the value of CF and PI, but still you guys do one mistake. What the mistake you do? The d is the derivative in terms of t. So whatever the answer you get in between, that has to come in terms of t only, and wherever the x has to be fed externally, the x would be fed as a e to the power of t, Anyways, if you want, you can come back to this here. That is what I did here. Here the x was fed as a e to the power of t, and there the few changes I expected. The x square d square y divided by of dx square was taken as d minus 1 of y. Similarly, x dy by of dx is being taken as d of y, or in totality x to the power of n is being taken as d minus 1 dash d minus of n minus 1. Yeah, like this. Is that part clear? So let me go back. Can you tell me what's going to be the best most answer? So see, the t was used as an alternate variable, but I need the answer in terms of x, so y would remain y. Instead, the e to the power of t, x has to be fed in. C1 will remain C1, C2, and instead the t we can feed ln of x, and in problem instead the C1 and C2 they have taken a as well as b, so you can even change that also. So it would become x would get multiplied with the C1 which has been taken as ax plus of bx ln of x. So what's going to be the best most answer? And may I know whether it's a particular solution or the general solution? Obviously it's the general solution. Why? Because the exact values of the arbitrary constants has not been fed in. There are so many number of problems have come from this particular zone, and you have to just follow this. Is this part clear to all of us? If you want the derivation, I would say need not to worry about that. Not at all required. Just focus over the keeping x is equals to e to the power of t, or keeping independent variable as a e to the power of t. Then you have to substitute this. So what will happen? The unwanted part, the x square, x to the power of 3, they were unwanted part, but they have gone along with this and they have become a f of d which is free from any x, or f of d which contains only and only arbitrary constants. From there you can get the value of CF as well as PI, and from there you can just get the answer out of this. Yes sir, clear, no? Okay. For the civil and mechanical, once in a while one question come from the partial derivative. You can see that part also. Write down. partial differential equation. Once the problem have come, and these problems are keep coming in mechanical as well as civil, so I can say it's very important for the mechanical as well as civil guys. So here the problem have come, yes, a dou is square u by of dou x square plus b dou is square u divided by of dou x dou y, c dou is square u divided by of dou y square plus d dou u by of dou x plus e dou u by of dou y plus f u is equals to of maybe input which is function of x and y. Its solution can fall in the three different categories. It could be hyperbolic, provided b square minus of 4ac is greater than 0. Similarly, it could be parabolic when b square minus of 4ac is precisely 0, and even it would be elliptical when b square minus of 4ac is lesser than 0. B square minus of 4ac is lesser than 0, ellipse. Again I would say you need not to worry about the basic behind this. Could you understand what I am saying? See what happens, sometime you would be experiencing a differential equation which is a type of partial differential equation. You can just compare the given problem with this pattern, you can just create it out, the values of a, b and c, and if they follows a certain rules, then from there at least you can figure it out what would be the type of solution. Still I understand many of the students will not be able to experience or will not be able to appreciate this question or this concept. You need not to appreciate at all, because it has got a good amount of derivation which has got involved with it. So I would say just keep aside those derivation and just focus on this. Is the part clear? So let me do one thing. In very fast manner, I am going to take few number of problems. Let me tell, so you guys have to tell what's going to be the best most answer for those. Yes, this is what the problem is. Tell me what's going to be the best most answer. And this problem have come in civil engineering year of 2016. The problem was framed by ISC Bangalore. Tell me what would be the answer for this. So you guys have to get the answer for this particular question, and then we'll take two more questions in fast forward. So you have to get the value of a, b and c. That's it. From there you have to get the value of b square minus of 4ac, which we also call discriminant. In class 9th or 10th we have studied, and if you have not able to recall, keep aside. Just focus over the b square minus of 4ac. Now the sign of b square minus of 4ac, whether it's a positive, negative or 0, it's going to decide which type of solution it will lead. So I need the answer from each one of you. So I want the input from each one of you. What's the value of A, what's the value of B, and what's the value of C? What's the value of A, B and C? Tell me. Hyperbolic. First get the value of A, B and C. First, write the value of A, B and C. I want the input from each one of you. 9 minus 4, which is greater than 0. Obviously C. That is what I said. Almost 5 number of times this sort of problem have come in civil engineering, mechanical engineering. So that is what I am saying. Just focus over a standard form of the partial differential equation. Focus over the A, B, C, and the value of B square minus of 4AC. The polarity basically is going to decide the solution would lead a elliptical or hyperbolic or parabolic. 1, 3 and 1. Obviously the A is gonna be 1, 3 and 1. So the B square minus of 4 A into C. So the B square becomes 3 square minus of 4 into 1 into 1. The 9 minus 4 becomes 5, which is greater than 0. And if B square minus of 4AC is greater than 0, the result would be hyperbolic. So the answer is simply gonna be C. Is that part clear? Now I want the answer for few more questions and then we'll freeze this topic. I want the value of particular integral. For this particular question, this problem have come in GATE Mechanical Engineering year of 2006. The problem was framed by IIT KGP. So probably within 30 seconds, now you guys must be able to calculate its PI. I want the answer for this. So what we will do? Solution. In case of Pi, f of d has to get operated with r of x. May I know what is r of x? It's nothing but the 3 e to the power of 2x. May I know what is f of d? F of d is nothing but d square plus of 4d plus of 3. And instead the d, I need to feed a. What is the a over there? It's just simply 2. So at numerator, it's simply gonna be 3 into e to the power of 2x. And instead the d, the 2 has to be fed in. It's gonna be 2 to the power of 2, that's a 4, plus of 4 2 ja, that's a 8, plus of 3. So the answer becomes 3 into e to the power of 2x divided by a 15. 3 divided by 15 can be written as e to the power of 2x divided by 5. Keep in mind, but in case of Pi, you are not going to get any arbitrary constant. Yes, the B is the perfect answer. Let me take another problem. Yes, the general solution to the differential equation y double dash plus 4y dash plus 5y is equals to 0. This problem have appeared in GATE Agriculture. I have deliberately taken a question from the agriculture engineering such that at least you should have a varieties of the field in your own domain. So may I know what's going to be the best most answer? B. But once you talk about this problem, the general solution, it's not asking about any particular solution, and even the particular solution, particular integral will also be 0. Why? Because the input itself is 0. Is that part clear? So how you are going to focus on? You're just going to focus on the auxiliary equation, which is d square plus of 4d plus of 5, which has to get compared with 0. And I would suggest to each and everyone, now you cannot calculate the roots of this quadratic equation with your soft calculator, so you should have the clear cut idea how do we calculate this root. So the best method is gonna be middle term split. If the numbers are found to be easy to separate, so here you can just calculate the value of d. It's a 5, no? Chalo. Find the value. And you will get the answer. Get this out. So here, let me go to the equation 3. Here the values are 1, 4, 5. So the values are coming. D is equals to of minus 2 plus minus I. The middle term split can be used only if the roots are found to be real and somewhat very is that part clear? So here it becomes very difficult to tackle with the minus 2 plus I, But anyways, easily you can get the answer out of this. Easily you can get the answer out of this. You can use the concept of Sridharacharya rule. And from here, the A is nothing but this becomes, and here it becomes A of cos of x plus B of sin of x. Sin of x. Is that part clear? So from my side, the concept of differential equation got over. And in tomorrow's class, we are going to start, or we are going to talk about the concept of linear algebra. Linear algebra. And in linear algebra, we are just going to focus over the important topic. We are not going to discuss about the properties of the different square matrix and then all. No, 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 no. The question do come from there, but rarely the question comes from those domains. So straight away, we'll jump into the very important domain like rank, like the different kinds of solution, rank, like eigenvalues and eigenvectors, eigenvalues and eigenvectors. So before binding the today's session, I would like to just take the feedback from you guys, which type of improvement we can have in our classes or videos. You can write over the comment box, and I would also suggest that each and everyone who are live with me, they should join my Telegram group, because any type of doubt, technical or non-technical, you can discuss over there. So you can write any type of improvement you guys are wanting and any type of inputs you guys are wanting, and then we'll move ahead and we'll meet tomorrow with the concept of linear algebra. Linear algebra. Tell me. I want the input in my comment box. Okay. Are you guys are liking my videos? If it is so, just give me a thumbs up or heart. So I'll get to know how far I could reach to your mind. Because the different teacher have got the different stories, different narration, different way of speaking. So just I wanted to know how far I could reach to your mind, to your heart. So I want the feedback. Okay. Sayan Datta, thanks dear. Srinath, thank you dear. Anurag, thank you sir, thank you dear. Asis Kurane, thank you dear. Animesh Jana, okay, thank you dear, thanks a lot. Anyways, love you all. We'll meet tomorrow with the next and new topic, and the topic is gonna be linear algebra. Is that part clear? Thank you very much.